Hello everyone, this is a supplemental video to the 3D printing and engineering design videos. And this video is primarily meant for teachers who need to understand the equipment that we're using to test the parts that have been printed, but students can also use this as well. In Module 2, students have to design an aerodynamic vehicle and then print it out to test it. And this is the wind tunnel that they will use to test their designs. So the most important part of this wind tunnel is at the end here, and this is the fan. So this fan has an adjustable sliding switch that you can see in the front here. And so when I turn it on, so right now it's at low power, and I can turn it all the way up until it's at full strength. And you can hear it too. It's pretty powerful when it's at full strength. And I recommend that for any measurements that you do with students' printed designs, you do it at full power, because otherwise the parts are normally pretty small, and you're not going to really get much of a measurement if you do it at low power. So make sure it's at full strength. And so I'm going to turn it down and then turn it off. And as a safety precaution, this fan is pretty powerful, especially when it's on full strength, and I would not stick your hands anywhere near it until the blade has completely stopped, because sometimes it takes a while after you turn the switch off for the fan to completely stop. So wait until then for to move the wind tunnel around, or else it might be a little bit dangerous. So, and another thing to consider is that the fan isn't actually connected to the wind tunnel other than these wires, and I use this binder clip just to keep the fan in place, which is what keeps snapping off. So now this is the body of the wind tunnel. This is where all the parts are to be placed. So the top comes off, you need to reach inside. But for this, I've found that just manipulating things from inside this end works just as well. So this is the arm of the wind tunnel, and this is where the hanging scale is placed. So this isn't really attached to the body of the wind tunnel at all. It just has, you can just place it in the middle, and that's what I find works best, to place it like this. And then it has 3 screws here where the hanging scale will be placed and go in the middle of. And so this brings us to the hanging scale, and this is what we use to measure the drag force of the parts. And this scale, unfortunately, doesn't measure force. It doesn't measure newtons. It actually measures in grams. So you have to multiply anything that this says by the gravitational acceleration to get the true drag force. And this hanging scale isn't very sensitive, so the parts do have to be somewhat large to get larger, more accurate readings. And you also have to turn the fan up high, and that's what I talked about earlier. So the hanging scale goes here. And another thing to consider is that the scale has a hook here, and it also has a smaller loop. And I've found that when you place, when you tie the sample up to the hook, you don't get accurate readings. But when you tie them to this little loop here, you get much more accurate readings, because this is actually attached to the internal structure of the hanging load, or the hanging scale. So I'll place the hanging scale in position. And so what I've done to measure the drag force of these parts is to create a little Lego cart, because if you try to put the parts in here by themselves, there's so much friction, and you'll have to tie it down somehow. It's not really worth it. It wouldn't work as well. So I've made this Lego cart here, and for each part, you'll have to glue a Lego piece to the bottom of each 3D printed part, and then attach it. And I found that this works really well in terms of measuring the drag force. So I've used dental floss to tie the Lego cart to the load cell. And so this is a scaled down model of a design that a student made. And so if I were to be actually using this, I would have glued a Lego piece at the bottom, but I didn't. So if there were a Lego piece here, I would attach it to the cart like this, and then turn the fan on and watch as the cart is pulled back as the air is blown through the wind tunnel, and a reading will be shown on the hanging scale. And I'm going to take this off because if it's not attached, it's going to go flying down into the fan, which is not good. But I'll show you how this works. And so as you can see, I started with some slack in the floss, and as soon as I let it go, it dragged it back and put some tension in the floss, and this is the force that it's measuring. So after you've measured a student's part, you also need to measure the velocity of the air in here and the density of the air. And to measure the density, you need the temperature. So to do this, we have an anemometer that has a little fan on the top that measures the wind speed, and it also has a temperature sensor that'll let you know the temperature in this wind tunnel. So when the fan's running, you can stick it in like this, turn it on, and it'll give a clear reading of velocity of the wind in meters per second, and then also the temperature in degrees Celsius. And to find the temperature, all you need to do is, or to find the density from the temperature, you need to look up some tables that can be printed out. This will just convert the temperature into its corresponding density of air. And these are the main things to know. Everything, there's a little, some little things, but everything else was explained here, and good luck.